Thank you. So yeah, Tom already went through most of that. The important line for this talk is this bottom one, BDFL Delegate for Python packaging, and I'll get more into what that means later. So Python packaging is, hang on, I just stuffed up the presentation sync here. There we go. So Python packaging is wonderful, great, perfect, doesn't need anything fixed whatsoever. It's all happy and, yeah.
It's a freaking nightmare.
Yeah, no. This is more like, the comment from down here is it's a freaking nightmare. Yeah. Newcomers and experts alike. Why is Python packaging so bad? And especially if you compare it to some of the newer stuff like NPM, it's like, what's going on? And it turns out there's all sorts of complicated social problems behind how it got the way it is. And one of the key things was that the Python package index has historically been a very hands-off setup. It's like, do what you want. We're not very opinionated. Just publish whatever. Turns out a lot of the problems are around metadata quality and making sure that what gets uploaded is actually usable, and so that needed to change. But that said, for the people that are currently using this stuff, as problematic as it is, they've done a lot of work to make it work for them, and we need to somehow manage to get to something better without breaking what's already there. Yet what's already there is occasionally horrendously insecure, so you can't make it more secure without breaking the insecure stuff. And so anyway, so the way people had been trying to tackle this social problem was they just try and suggest modest changes, like small improvements. But the problem was the small improvements would still break stuff, and you weren't getting any big payoff at the end, so it was like, oh really, let's just not bother. And so it was a thing of, well, we needed to find a way to actually say yes to some of the more ambitious stuff and actually say, okay, fine, yes, there's gonna be some pain in the transition, but hey, at least we'll be in this much better space at the end. And so one of the things we actually did was we actually changed the way the Python Enhancement Proposal process works. Because historically, every PEP had to go through Python Dev. And that Python Dev was the only place where an enhancement proposal could be accepted was actually on Python Dev. But that's actually a real problem when the PEP is about a topic that Python Dev doesn't have expertise in, and packaging was one such topic, because on Python Dev, we're mostly interested in new versions of the language, where's the language going to be in 3 or 4 years, not what can we do right now to fix packaging for people who are still using Python 2.6 on RHEL 6, or people who are using Python 2.4 on RHEL 5. And similarly for all the other stable Linux distros that are running integrated versions of Python. And so what we actually did last year was we changed the way the PEP process works, such that it can now be used by people who aren't Python Dev. And so when it has a discussions to header, so most significantly for purposes of this util sig, that PEP may actually be approved without Python Dev getting involved at all. That said, there's core language and standard library stuff still has to go to Python Dev. That's still our problem. But it also involves this idea of a BDFL delegate. And what a BDFL delegate is we realized a few years ago, Guido doesn't scale. And so Guido van Rossum's Python's benevolent dictator for life. And the way the PEP process originally worked was that every PEP had to be approved personally by Guido. He was the only person who could say, yes, we're going to do that. That really didn't work well for problems that Guido found incredibly boring and just wasn't interested in at all. Packaging is one of them. And so what the original change was basically to the idea of a BDFL delegate, which is essentially Guido saying to somebody, I trust you, you make the decision, I don't care. And that's kind of changed a little bit, where it's more a case of, hey, can I be the BDFL delegate for that one? And if Guido doesn't say no, then it'll probably happen that way. But yeah, and so the details of all of that stuff is in PEP 1. And that's kind of the meta PEP about how the PEP process works. But yeah, this is the kind of scale of social unbreaking that we had to do to even start trying to fix stuff. So anyway, as the end result of all that, we now have this thing called the Python Packaging Authority. And as a result of a bunch of those other changes, we were able to finally adopt, for packaging stuff, an ecosystem-first model. And then if the standard library plays catch-up later, awesome. If not, oh well, we'll find a way to get the tools onto people's systems. And so what it meant was that distro went from a position where they had to, having come to a resolution on distro, they used to have to go to Python dev and say, please can you rubber stamp this? And there'd be a whole new round of bike shedding, and it was all thoroughly unpleasant and nobody wanted to do it. And so now instead, distro is actually the decision-making authority for almost all Python packaging stuff. And so for general PEPs, it'll usually be me making the final decision, and then Richard Jones takes care of the actual Python packaging index itself and the PEPs related to that. And basically the upshot of all this was that it kind of really changed the mood of distro. So for a long time, it was an environment where you just tell people, steer clear, it's toxic, don't go there. But with all these changes, where people used to be in the mode of going, everything's broken, there's nothing we can do about it, oh well, we'll just continue trying to make the best of it that we can. The mode now is more, yes, lots and lots of things are still broken, but we are making progress, things are getting better, we can actually see we might actually have many of these problems fixed someday. There's still a hell of a lot of work to do though, but because the environment's no longer so toxic, we're actually willing to ask people for help because we don't feel guilty about it anymore. We're not saying, hey, come into the cesspool. And so it's that shift in mood just makes a huge difference in terms of asking people to help out and actually having the energy to continue trying to improve things. So this was if anyone was at PyCon.au last year, I spent a lot of time talking about the near-term stuff we'd been doing. And the focus near-term is basically eliminate any need to ever run setup.py install on a production system ever, because that is evil. And so one of the big things is Python 3.4 will come with pip. The way we did that is not happy making for distro packages, but the Fedora guys are trying to work on a slightly different way of doing it that makes them cry less. And so hopefully that'll be useful for Debian and other distros as well. But the big advantage for that is that one of the big problems we had with the ecosystem as it stood was beginners getting started with the packaging tools was really, really difficult. And that was the fault of both the fact that bootstrapping pip on Windows was incredibly painful, but also the fact that if you looked at the standard library docs talk about this infrastructure that's in the standard library, whereas in reality, if you want to preserve your sanity, you don't try to use that stuff directly. You use stuff like pip, you use Setuptools, you use Twine to do uploads to PyPI, and all of those other tools are basically the cross-platform glue, the cross-version glue that's consistent, that will let you support back to Python 2.6 or even back to Python 2.4 if you want. And so that's kind of the first step of trying to get this stuff out of being a responsibility of the core development team, because it's not really something we're interested in, into the hands of people who do deeply care about it, which is distro SIG and the Python Packaging Authority, and those folks, and give them the ability not only to implement the tools, but also improve the tools, improve the standards, and actually move the ecosystem forward. And that splitting the responsibilities that way just works a hell of a lot better than trying to funnel everything through Python dev. One of the other things we'd been missing was Python packaging historically has been very much an install from source model. and that binary repackaging was a distro problem. Again, not something that works well on Windows, not something that works well with the Python installers on Mac OS X. So Daniel Holth came up with the wheel format, which is basically an upgrade to eggs that addresses a bunch of the issues that limited their adoption. So the stage wheels are out at the moment. PyPI allows you to publish them for Mac OS X and for Windows. We don't currently allow them to be published for Linux or any POSIX system. So on those, they're useful as a build caching tool. The reason we don't allow them to be published on PyPI at the moment is that if you try to build a wheel on Linux at the moment, it will get tagged as Linux x86-64, regardless of what binary dependencies you had. And funnily enough, those often won't work on if you build them on Debian, they usually won't work on Fedora. If you build them on Fedora, they usually won't work on SUSE. If you build them on SUSE, they probably won't work on RHEL. So we need to come up with a better way of tagging before we can allow the POSIX wheels to get published.
What's a wheel, sorry?
Sorry, so wheels were the... so eggs have been around for years as a binary format. Their adoption was limited both because of their association with easy install, which has some really strange defaults that make people angry. But they also had some serious limitations in the way they were named in terms of figuring out publishing non-conflicting wheels for different platforms, non-conflicting eggs for different platforms and that kind of thing. And so wheel was designed to fix a bunch of those limitations with eggs. And that then, so it has now, so Python 3.4, because it bundles pip, comes with the ability to create wheels out of the box. And so you can just do pip wheel, and it will create a binary for you. And then the Python package index gained the ability to distribute those. Yeah.
For those of us who aren't familiar with pip, would you mind giving a real brief intro, please?
Oh, okay, sorry. Yes, I should have asked that. So pip, who's heard of easy install and Setuptools? Okay, so easy install has a bunch of really, really strange defaults because it was born out of the Open Source Applications Foundation's Chandler project. And so a lot of the defaults on easy install are built around the idea that you're building a single integrated application. And so if you run easy install in a system Python installation, you'll make your system administrator cry. A lot of the defaults, because they were built around that Chandler use case, are just very, very strange for anything else. And it does weird things that make it not work like the normal Python path. And so it just annoys people. And so basically what pip did was, pip is built on Setuptools and uses a lot of at this point, still uses a lot of the same infrastructure, but essentially changes the defaults to be more in line with what people expect. And so it was a case of, but a lot of the changes they made couldn't be done in easy install itself because they were technically backwards incompatible. And so pip is the one that, while it's far from perfect, and they're always willing to accept new contributions, proper dependency resolver would be wonderful. That was the one we basically picked as the best of the current ones for inclusion with the default core Python builds. And so basically, we're aware it's far from perfect, but we also think it's the foundation that we want to build on and basically do incremental improvement within pip rather than waiting for somebody to drop something perfect in our laps, because that's never going to happen.
So wheels is the format that pip uses? Is that what wheels is?
Wheel is kind of aiming to be the upstream Python equivalent to a binary RPM, so that basically, because one of the core problems was that when the original Python infrastructure was built, it was in an era where the main target was Linux distros, and the assumption was that people using Python also knew how to run a C compiler, which in the late 90s probably wasn't an unreasonable assumption. 2013, not so much. And so wheels Wheels primarily were actually aimed at beginners on Python, on Windows, because asking a Windows user to build NumPy, that's just cruel and unusual punishment. Asking them to build, so building NumPy, building WX, building that kind of stuff. You just can't ask a beginner to do that and expect them to do anything except walk away. And so Wheels were basically designed at tackling that problem in a cross-platform way.
Pip on Linux today doesn't use Wheels.
So pip on Linux will use Wheels for build caching. So if you're doing virtual environments and stuff, it can cache the wheels so that next time you do a virtual environment, it can just install directly from the wheel rather than having to do the build again. There are currently limitations of our compatibility tagging system where we don't make a fine enough distinction between Linux distros, so you can't publish Wheels on the Python package index for Linux. You can publish platform neutral ones, you can publish Windows ones, you can publish Mac OS X ones, but the binary compatibility problem for Linux is such that we don't currently let you publish Linux ones.
On Linux, what is it installed? Where's it coming from?
It's still coming from PyPI, but it will install from source.
Okay.
So, which is the way, which is...
It's fine for most Linux people.
Yeah. Because that's the thing, is the binary problem was most severe for people installing the binary installers from python.org, so Mac OS X and Windows. And that was the combination of probably not having an installer, because, probably not having a C compiler, because it's a separate download and install. You have to get Xcode or you have to get Visual Studio. And just generally often not being they're people learning programming, so using a command line at all is a novel experience, let alone building software from source. So that's the stuff we've been doing in the last year, is basically trying to make that new Python developer experience far more streamlined, far more pleasant, basically far more welcoming, and putting off the point where they need to learn to deal with.
Less masochistic.
Yeah.
A lot of people with lower pain thresholds.
Yes. And so it's basically bringing the language up to speed with the fact of basically putting off the point where they need to learn what C is, basically. And so you see that in Python 3 as well, which is a lot of behavior we'd inherited from C. We're like going, well, that's not appropriate anymore. So we shift to something that's more in line with the expectations of new users. And then the other major near-term thing that's been going on, so the Python package index itself, so like the actual server software running that powers Python PyPI, that again is on the order of 10 years old. It's this old Zope2 thing that nobody quite understands and was in the era before unit testing and functional testing of web applications was a thing. So making major changes to that code base is probably a really, really bad idea, because you'll probably break something for somebody. And so Donald Stuft, Richard Jones, Alex Gaynor, and a few others are currently working on a thing called Warehouse. And so at the moment, Warehouse is focused on becoming a modern, trying to think what framework it's in. I think it's Django. So it's either Django or Flask, I'm not sure which. And it's basically designed to be a modern Python web application, built, unit tested from the get-go, and actually making sure that it properly implements PyPI as it exists today, so that they can migrate it over and hopefully not break anything, and then have a much better foundation for adding the new stuff that we want to do.
Yep. Yeah. What version of Python will the version of pip that supports Warehouse be targeted at?
So Warehouse is the existing PyPI API. It reproduces it exactly. So all current. So that's that's one of the big things that's actually coming out of Warehouse is, and some of the creators, Holger, the creator of DevPy and stuff, their test suites have actually been really helpful as well, which is that actually having a test suite that says, this is how the PyPI server should behave, because with the legacy PyPI code base, we don't have that, which is what makes it so fragile. And so that test suite is kind of one of the biggest things to come out of the thing. One of the other things Warehouse does is it pushes a lot more of the data integrity conditions into the database. So you're far less reliant on the application code doing the right thing, because the database just won't allow the invalid data to go in there. And so then the other big thing that's enabling is the update framework guys, if anybody's ever heard of those. They've done a lot of work on how to do end-to-end secure distribution from developer to end user in a way that isn't it is horrendously complicated, but you aim to try and hide as much of that horrendous complication from the end users as possible. And PEP 458 covers a bunch of that stuff. And once we have the new PyPI that we can actually modify without breaking the world, then that will kind of be the next step, is getting that into place and actually having end-to-end signing, so that the whole idea of trusting PyPI becomes a little bit less scary. However, as a Linux conference, that's useful for the Python people, but there's some other technical issues that we want to fix with the current packaging system. So like, again, current Python metadata standards come from a world before 2006. So they're a world from before JSON was a thing. And so it's this weird mix of Python-specific formats that you have to figure out how to read. You can't just throw it at a JSON parser. And another thing, this again gets back to the PyPI limitations. PyPI doesn't actually publish the metadata. You actually have to download the distribution to look inside it to find out what its metadata says, and that's just madness. So we'll basically be, as part of the PyPI stuff, Donald and co are also working on the APIs that PyPI exposes to actually make more of that metadata available without downloading things. However, there's a more general problem that I don't think anyone has really solved very well yet. And it's this one. Cross-platform distribution tools are wonderful. It's like, aren't they? They're perfectly awesome. I can tell my users, I don't care if you're using Debian, I don't care if you're using Ubuntu, I don't care if you're using Fedora. Hey, you can even be using Mac or Windows. Here's the instructions for how to install my stuff. They're great. No, they're awful. Terrible, terrible things. It's like C, C++, Java, Python, Perl, Ruby, JavaScript, Haskell, Erlang, Rust, Go. How many different packaging systems do you want me to deal with as a system integrator? It's like, oh look, here's a new language community. They're repeating all the same security mistakes as every language community before them. It's like, and then it's like, how do I know what's on my computer? Well, you ask the Python stuff, ask the Ruby stuff, ask auditing and certification. They're a thing. People need to be able to do them, and they need to be able to do them without driving themselves to drink. So I would like Python packaging to play nice with Linux distributions. It's like, cross-platform packaging tools have their place. It's like people want to write cross-platform applications. They don't want to have to learn the fine details of what Debian's rules are, what Fedora's rules are, how to do a compliant Windows app. Developers just want somebody else to deal with the packaging problem. And that's what cross-platform packaging tools are about. But on the other hand, system integrators don't want to have to learn every single language-specific packaging tool on the planet. They want to be able to just use the one provided by their platform and know everything that's on their system. And this is actually annoyingly hard. So I got involved in all of this stuff after I started working for Red Hat. And I was having to bring dependencies in from PyPI and figure out how to get them to play nice with Red Hat's build system. And it turns out that all the upstream tools are basically going, oh, well, we'll just take the upstream source format and turn it into a downstream binary format. And you're going, that's all well and good, but I need the downstream source format to feed into the build system. And that stuff just wasn't there. You had to do all of this manual stuff to get a policy-compliant spec file. And it was just painful. However, it's not a problem the distros can fix because the metadata they need isn't in the upstream metadata. So they need a format to add it. And that format is naturally going to be the platform-specific one. But then it meant that all these distros were repeating all this work to add this platform-specific metadata in the platform-specific format, even though it was probably pretty similar. And it would be nice if it could just be, it would be nice if the upstream format was just a little bit richer, had a little bit more information in it, perhaps a little bit more extensible, so that instead of having to go, oh, I'm going to create my own platform-specific packaging thing, I want us to get to a point where the distro package can instead go to upstream and say, hey, can you add this extension to your upstream metadata so that I can automatically generate a downstream package, and in most cases, hopefully, we can just make the process of doing an update relatively painless. And so that's what PEP 426 is about. PEP 426 defines the packaging metadata 2.0 standard for Python. It's a really quite a complex data model, but it's dealing with really quite a complex problem. So it's, if you narrow your scope to just dealing with software as a service web applications, you can do quite a simple, elegant distribution model, and the distros will hate you. And if you completely ignore the binary distribution problem, which is what Python did for years, you can have quite a simple data model, and your users will hate you. So it's basically a case of, okay, a matter of admitting that complex is better than complicated. So we need to stop denying just how complex the distribution problem is and start trying to build our distribution system into one that can handle it. And so basically, metadata 2.0 is a JSON format, extensible JSON format, and it is aimed primarily for use in APIs and as a serialization protocol for communication between tools. It's designed to be human debuggable. Excuse me. Not really human readable is not really a priority, and human editable definitely isn't a requirement. Our expectation is that tool developers will put a suitable front end that humans can actually deal with. So like Setuptools, for example, will most certainly continue to use setup.py. And then the other thing about it is that it's deliberately designed so we can distribute it in parallel with the existing metadata. And so what that gives us is that gives us a lot of flexibility in terms of how we do the upgrade, in the sense of, so if we're publishing legacy metadata and the new metadata, old tools will continue to work, but new tools will hopefully gain new capabilities that are quite beneficial. And so one of the key differences between metadata 2.0 and the 1.x stuff is that it is deliberately designed to include the notion of redistribution. And so in the data model, there actually isn't the idea of system integrators. There is the idea of system redistributors. And what we're trying to enable is for distro packages to be able to work with upstream and with the upstream packaging system rather than having to fight against it every step of the way. And have upstream telling them, oh, but you're doing it wrong. You should just install stuff using the language-specific tools, because that's not the way to do it if your system needs to be audited or if you're security conscious or that kind of thing. And one of the other key things where I was talking about the metadata standard being really opinionated, it's really, really designed to strongly discourage version pinning by upstream. Because version pinning is a job for integrators. So it's the integrators who say, this specific combination of versions have been tested together, they work together, this whole thing forms a coherent application. Publishers should be saying, basically this set of versions should work, but we may not have tested all the possible combinations, and leave it up to integrators to do their job. And so one of the key parts of that is actually updating the versioning system. So historically, Python's versioning, we inherited Setuptools kind of pretty much borrowed from CPython, and CPython has a very flexible approach to version ordering, so that the way it actually orders stuff is usually pretty intuitive, but it's not formally defined. It's just kind of, it's an implementation defined thing. That
You mean people can just do whatever they want?
Hey?
You mean people can just do whatever they want?
And it's a very Perl way of doing things. Let people do whatever they want, and the tools try to figure it out. And they'll usually give a reasonable guess, but when things go wrong, you have no idea how they're going to go wrong. And they may not go wrong, they may just give the wrong answer. That's special. And so yeah, this was a model that, and this was actually one of the problems with Setuptools, because it was closely modeled on CPython, and CPython has a very Perl design mindset. A lot of Python people looked at it and went, oh my God, it does what? And so this was actually one of the barriers to more widespread adoption of Setuptools, was that people really didn't like the fact that Setuptools behavior in edge cases often wasn't clearly defined. That the failure modes weren't clear, they were just whatever the implementation happened to do. And so what we've done with, so there's actually PEP 440 is specifically devoted just to the versioning system. And it's essentially defining the way Setuptools versioning works in a way that's compatible with like 99.8% of the Python package index, something like that. And one of the key things from a distro point of view is it actually has the explicit notion of an integrator suffix. So when you put an integrator suffix on it, you say, we have added extra patches, but we have not changed the API. And so for version matching purposes, the tools will only look at the first part, and if the first part matches, then yes, that's a correct match on the version, but you can still indicate the patch level actually in the upstream metadata, rather than having to do all the various hacks distros do today. And then the other thing is moving to semantic versioning for dependencies by default. So you can pin if you really want to, but the tools will strongly encourage it and will actually issue warnings if you pin stuff in the wrong place. And then more flexible options like prefix matching, that kind of thing. Because not everybody does semantic versioning, and even if they claim to do semantic versioning, they often don't. Semantic versioning is just the thing of if it's a maintenance release, so 1.x, 1.1, 1.2, 1.3, you should be API compatible. But if it goes version 1 to version 2, then there may be API breaks.
So it's the whole major line of
Yeah. 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 So semver.org is, or PEP 440 goes through a lot of that stuff as well.
You're saying pinning to a maintenance release or pinning
People
to a...
do it. People pin to an exact version, and it makes security updates a nightmare. And if anybody was here for the open programming talk about versioning in Ruby, it's exactly that problem. That people upstream pin dependencies, and then it just causes pain for system integrators because they can't do security updates properly.
Is that just because they don't really know what they're doing?
Yeah, a lot of them are just people hacking in their bedroom. They've never built a large-scale system. They don't understand the notion of what a security update is. And so one of the key themes of Metadata 2.0 is for the packaging server, for the index server to be opinionated on behalf of the integrators who are going to suffer the consequences when people get this stuff wrong. And it just makes it easier for people to learn from the warnings the tools are giving them. Oh, okay, this, basically trying to nudge people into good software engineering practices, even if this is the first thing they've ever built in their life. And then hopefully further down the road, they will actually understand why these things are important. So the other things are, So historically, Python's only had, so anybody who's used Setuptools, it only has two kinds of dependencies. It has requires and it has install requires, which is kind of equivalent to a runtime and build time dependencies. Those aren't quite rich enough, so Metadata 2 has 5. So build, test, and dev are hopefully reasonably obvious. Those don't need to be installed on production systems. They need to be on build servers. They need to be on your dev machines. Sorry, only this needs to be on build servers. So run and meta are interesting. So I was talking about discouraging version pinning. There's actually one valid use case for version pinning, which is meta distributions, where you're not actually, where the component doesn't actually, where you're actually kind of being an upstream integrator. So PyObj-C is an example of this, where there's actually multiple PyPI projects, and then there's an umbrella project that you can download that'll just grab all the others. And so that's kind of a case of meta distribution where whenever any of the components get upgraded, the parent project will get upgraded as well. So in that case, version pinning is the right thing to do. And so in that case, you'll do a meta dependency, and you'll say, I am redistributing this, and if this needs to be upgraded or needs a security update, I'll deal with it. And the other thing, standard metadata extensions. So historically, the Python metadata wasn't extensible at all. If we wanted to add new fields, we had to upgrade the main spec. We've redesigned it in 2.0 so that as much as we can, we've actually pushed out to an extension system. And so all of the stuff that you don't actually need to do dependency resolution is all in extensions. One of the interesting things this let us do is by putting the project contact metadata in an extension, what we actually do is, in addition to having project metadata for the upstream project, that contact metadata you can also provide as a system integrator. So there's a separate standard extension where you just say, this was integrated by whoever. So for instance, a Fedora repackage might say, here's the upstream metadata for IPython, say, but then also have a separate contact field as the integrator saying, these are the maintainers of the IPython package within Fedora. And so the upstream metadata, again, having that concept of integrators and redistributors as a first-class entity in the data model. Now that said, our focus at the moment is still on that near-term stuff I was talking about earlier. Until we get end-to-end security on the Python package index, this will still remain a work in progress. That said, a lot of it is driving the data model restrictions in PyPI 2 as well. So PyPI 2 is in a lot of these more opinionated things. Warehouse will actually start enforcing them even before the spec gets published. And so one of the reasons why I submitted this talk for linux.conf.au is one of the things we really need is more feedback from distro people saying, will this, or have we done enough in the upstream spec to make it possible to automatically generate distro policy compliant packages? Because it's one of those things. If you look at a lot of the upstream guides on using native packages, yes, they're fed into the native packaging system, but they don't meet anybody's policy guidelines, so the distros can't use those tools. And what I'm aiming for with this is I want to automate the process of actually making the distro packages themselves. So that, yep, and that's a few more links for more info, and yeah. Yes?
Presumably your mission is your interface inside Warehouse to make sure that this works with
Yes. Please. Oh, sorry. So the question was whether I'm the interface within Red Hat between the Python upstream and the Red Hat guys.
The question is has Canonical and Debian project got one this?
So nowhere near as closely.
Question, repeat the question.
Oh, sorry. The question was whether Canonical and Debian, Canonical/Ubuntu and Debian are as closely on board with this. The answer is not yet. I occasionally bug Barry Warsaw about it. And we do have some feedback from a few Debian folks saying, yes, that looks sensible to us, but I'm certainly far from a Debian expert. I'm not even an RPM expert. I've just learned through pain and experience. Yes, that's one of the reasons why I'm here. I'm going, we need more help from the distro people to say, are we completely off base here, or are we going in a useful direction? Yes.
Are you talking to any Windows guys?
Are we talking to any Windows guys? Yes, because although Windows is actually perversely less of a problem because they don't have their own packaging system. So that's actually one of the main drivers of why the cross-platform tools exist, because we have users on Windows and they need a dependency system. Yes?
Have you consciously decided to not use version epochs, or haven't you considered those?
Version epochs?
Okay, let's say someone starts out with a versioning scheme that goes svn-date format, and then they decide, oh yeah, maybe we better go with semantic versioning, and so they bring that in. What a version epoch in Debian is that you have a way of deliberately tagging a version as belonging to a new epoch, so that your sorting then works. And effectively, the version epoch is a digit and a colon before the upstream version number, or it's added to the upstream version.
No,
So you're saying versioning.
Oh, sorry. So the question was
versioning for versioning.
The question whether we'd considered using epochs to deal with version scheme changes, and the answer is no, we hadn't. That's a very interesting idea. Okay, one last question. So,
Yep.
All right. This is kind of a horrible question. Sorry. In my environment, I've got a bunch of rel 5, some 32, some 64, a bunch of rel 6. We've got some Python apps that we're delivering. Some things are installed with distro. A lot of stuff with pip. Now start to use virtual env. Quite a lot of things I've been writing spec files for all three to package things. Is there a kind of a best practice for how to maintain your environment, which try and bring it all down to one package manager and not have all this kind of different, everything's been, all these dependencies that are across all these different packages.
the short answer is no.
the longer answer is this is why Red Hat's exploring software collections, just because we know it's broken, and that there needs to be better tools for this. Did I repeat that question?
No, you didn't.
Yeah, anyway.
That's a conversation, not a question.
Yes. Short answer is
one of the reasons I'm doing this is that
no, there's not a good, clean answer for how do you get from upstream packages to clean, auditable downstream systems.
And remember LSP.
Yes.
Thank you very much. On behalf of all Python developers everywhere, I think I say Godspeed.